Welcome to an overview to mainframe application development. My name is Philipp Brune from the Neu-Ulm University of Applied Sciences. Mainframe application development covers mainly mainframe applications cover two main areas of processing or of two types of data processing. And these are the batch processing and the online transaction processing, or OLTP type of applications. So these are the two areas where mainframes are classically used to implement business functionality. Batch processing, the name comes from the original punch card badges, which were really physical badges. Nowadays, of course, these are just implemented in software. And batch processing deals with the asynchronous processing of high data volumes in the background, so without user interaction, and is usually used for all the tasks in a company that, for example, are time-related, like booking the salaries at the end of the month or booking the end-of-day data and so on. Everything that is sort of a background and asynchronously processed. Usually on the mainframe, these are implemented using the job control language and the job entry subsystem, the JS, which we already heard about in the overview on ZOS. On the other hand, mainframe, or one of the strengths of the mainframe, is online transaction processing. This is usually, this is software that deals with the online interactive processing of business transactions, for example, bookings, orders, and things like that. And these are typically online, so they are synchronous, and there's a huge number of transactions in parallel. Just think of a retail store where every good that is moved over the cashier machine is, for example, booked out of the stock. So every single product then would create a transaction. So that is a huge number of transactions. And if you think about big companies like, for example, Walmart, which we heard already, a big retailer, then you have a huge number of transactions. And typically for these kind of systems, we need transaction processing monitors as middleware component, like, for example, the KICS, the Customer Information Control System, to implement these kind of high-volume transaction throughput applications. Ensure the ACID properties and implement distributed transactions. We will learn about all these things in the subsequent chapters. So this is just a short big picture. We have two classes of systems, batch processing, online transaction processing, and the mainframe has concepts for both. And when we talk about mainframe application development, we have to talk about concepts and tools and languages for these two big areas of applications. Regarding programming and implementing applications on the mainframe, regarding the programming languages, for example, we have different types of tools to implement job control, controlling batch processing. We typically use JCL, the job control language, under ZOS, but there are also other possibilities, like, for example, the language Rex, which IBM featured some years ago for most of their platforms. And you can also use TSO procedures, but this is less common, so scripting TSO commands and execute them as a job, that's also possible. Regarding implementing business functionality, programming languages, on the ZOS and also on the mainframe, we have different kinds of tools. There's, for example, classically the high-level assembler. In the past, even business applications were partially written in assembler language. So there's the high-level macro assembler on ZOS, which is a very powerful assembler language that resembles higher programming languages. So it's very expressive regarding more abstract constructs. Then, of course, one of the most important languages for mainframe software development is COBOL, the Common Business-Oriented Language, a very old, one of the first higher programming languages that still is around and still plays a major role in enterprise software development. There's another language called PL1, which is more or less an IBM product and only common on IBM platforms, today mainly on the mainframe, which is also used for writing business applications, but it has a smaller installed base than COBOL. And of course, all the other languages that you know, C, C++, classical languages, or Fortran, are as well available on ZOS. The second important language today, of course, is Java. On ZOS and on Linux, it is an important language for implementing applications in business and on the mainframe. And IBM has, for example, invested a lot to make the mainframe one of the most performant and powerful Java platforms. And combined with Java, of course, you can run all Java JVM languages like Scala, which is important for big data, but also, of course, scripting languages like PHP and Python and so on are available on the mainframe. Another kind of software language environments that is not so well known today are the so-called fourth generation languages, 4GL. This comes from the past when there was one considered higher programming languages the third generation, and then people said, okay, that's something beyond higher languages is fourth generation. These are more like software environments for creating business applications, and one of the most prominent examples of that is the Natural platform by the German Software AG, which is used to implement business applications. This was some sort of dead-end route for languages. The 4GLs were not really taking over the full software development market. Nowadays, this is more like a legacy technology, but still is used. And of course, we need databases to implement business applications. And on the ZOS and mainframe, of course, the most classical database systems is DB2, which is a relational, one of the first relational database systems, and IMS, which is a database management system that's even older than DB2, and it's a hierarchical, non-relational database system coming from the MVS or ZOS environment. And today one would say this is kind of a NoSQL database. So all the ideas are coming back at some point in time in computer science. If we look at the languages, of course, here's a history tree of and evolution of the languages. And you see COBOL is on the top. It's one of the first programming languages in the 50s already. The specification started, and it was very influential for other languages, but still is one of the major languages for developing enterprise applications. And here you see an example. This is just a screenshot of a simple transactional COBOL program. Transactional COBOL program that should be or could be run on the CIX or KIX application server. And you can see the COBOL code here is green and red and white, and the blue part here are some special commands that are basically macro language commands to interact with the CIX transaction monitor. We will have a deeper look on that when we discuss transaction processing. What you can see here is that COBOL is very strict about the indentation, and all the commands need to be formatted in a certain way, need to start at a certain column, and this sometimes makes it hard for beginners. Besides this, the language is very self-explaining. It's close to the English language. You can see identification division. There's a lot of wording here, a lot of text. That is, the idea of COBOL was to create a programming language which resembles the natural English language. So people which are not IT experts should be, the idea was that they should be able to read the program. So it's sort of like a natural text. And we will have a deeper look on COBOL also in this chapter. Of course, today people are developing business applications with modern client tools like the Eclipse IDE, and there are nice plugins which allow to write COBOL code, as you can see here with the Eclipse, write it on the PC and then test it remotely on ZOS mainframe, for example. So also for mainframe software development, of course, the modern tools like Eclipse and Git and so on are available. Nowadays, for some years now, beside COBOL, probably the most important language on the mainframe is Java. So it increased a lot in recent years because it's so common to use for business application development. And as you can see, Java is sort of on the other side of the history. It's a rather modern language from the 90s compared to COBOL. And Java is now supported more or less for everything on ZOS. It's supported using the so-called Unix system service environment. So you can write transaction code in Java, and you can also write batch processing programs in Java. And of course, you can use Java with more or less the same JVM implementation, very performant on ZOS as well as on Linux on the mainframe. And with Linux on the mainframe, you have, of course, all tools and components and software, open source tools available for Java development that you are used to from any other platform. A final look on Java involving, we will have a look on Java as well. So Java is not only a programming language. Of course, in the core, there's the Java Standard Edition, which is what you typically install when you download the JDK. The Java Standard Edition is the language itself, the compiler, the runtime environment, the JVM, and the standard APIs and the corresponding libraries. However, to develop business applications in Java, you need to know more. And you see that the next level is the so-called Java Enterprise Edition, as it used to be called. Just recently it was renamed to Jakarta EE and was sort of set free to the open source community, handed over to the open source community, and is now maintained by Apache. And this is basically a specification. So Java SE is also a product, the JDK, but Java EE or Jakarta EE is first of all is a specification that specifies an environment for writing business applications, which involves web front-end, web server, transaction processing and things like that. And this specification then could be implemented by whoever likes to implement it. So there are many different implementations that are all Jakarta or Java EE compliant, like for example commercial ones and open source ones. So there's the JBoss or Wildfly server, which is a free open source implementation, but there are also commercial implementations, like for example IBM WebSphere or Liberty for ZOS. So there is nowadays the new Jakarta EE server by IBM is the Liberty, which is available in an open version for all platforms called Open Liberty, and there is also Liberty for ZOS, which is a licensed product. And beside this, of course, Java is more than just the official specifications. There is the Java ecosystem around, which is a huge ecosystem of open source tools and projects that over the decades evolved around the Java language. There are different IDEs. There are all these projects from the Apache Foundation. There's the Eclipse and the Eclipse Foundation with all the projects. For example, JUnit is a very common tool. We have the Spring framework, we have the Play framework, and we have other languages for the JVM and so on. So becoming a Java developer involves not only the knowledge of the language, but also the knowledge of the ecosystem around. And in what follows, we will have a short view on Java, and we will later on have a view on Java or Jakarta EE as a platform for implementing transactional business applications, not only on the mainframe, but of course playing an important role on the mainframe. Thank you very much.